Alright, MSN 111. Right, so let's look at the test revision. Okay, so test 1 revision. Okay, so let's start from question 2. Start from question 2. Alright, most of you are quite familiar with question 1. We did a lot of practice on that. But I think preferably start from question 2, right? So question 2 deals with the binary. Question 1 is about sets, right? So question 2. Okay, so for the sake of someone, okay, question 1b, right? Basically speaking, 1b says the inverse set is given as negative 5, 10. Alright, x is given as negative 2, 7 open. Y is given as open negative 1, 4 closed. And Z is given as closed negative 3, 6 closed. Right, so the first question says find y complement, alright? So y complement simply means remove y from the inverse set. I think that's the most basic way I can say it. Remove y from the inverse set. So what remains in the inverse set after remove y? So what I'm going to do is I'm going to write the line for basically the inverse set, alright? So from negative 5 up to 10, then I'll write y is negative 1 up to 4, alright? So if you look at this, it's instead of using the open and the close, what I'll do is whenever I don't shade it, it's open, and when I shade it, it's closed, alright? So I'll open here and I'll shade there, meaning it's actually closed. It's the same thing if you wrote the open brackets and the closed, alright? So this is y. So what is y complement? So if it's open here in the complement, it's closed. So if I remove this part from the inverse set, alright, so that just shows that I've removed the y from the inverse set. What remains in the inverse set after I remove y? So since negative 1 is not part of y, it has not gone with y, it has remained. So this is now going to be closed. Up to there, negative 5 was already closed. So this is y complement, alright? Then again here, the 4, has the 4 gone with the y or it has remained? It has gone with the y. So since it has gone with the y, it's now going to be open, alright? Then up to 10, what is happening at 10 is closed. So this is y complement. So I'm now going to pick my y complement, what has remained. So y complement is basically going to be negative 5 up to negative 1 closed, because it's shaded on both. Then the gap with union, then it's now open at 4 and closed at 10. So basically speaking, that's how you find y complement, alright? So that is your y complement. So what you need to know simply is, it's as simple as that. You just write the inverse set, alright? Then from the definition, the y complement, you simply move the y from the inverse set. Alright, so I've removed the y from the inverse set. This is what I've done. Then from there, I'm just showing that since the negative 1 has gone, it's now going to be open. The 4 has gone, but it's actually part of the y, so it's now open. It's the opposite. So the complement assumes the opposite. So if it was closed here, it would have been open. Alright, so that is how you find y complement. Alright, so let's look at the next question. Let's look at the next question. So the next question says x union z complement. X union z complement. Alright, so allow me to skip that one. It's the same principle, okay? It's the same principle. It's basically the same principle. So, okay, x union z, so we start with finding the union of x and z. So if I'm combining x and z, I'm going to pick the smallest in one set and the largest in the one set. So I'm going to compare, since I'm looking for x union z, right? So x union z, what you do is you compare the two sets, x and z. You pick the smallest in x, right? So you pick the smallest in x and you compare with the smallest in z. So the smallest in x and z is -2. What is happening at -2? It's closed, right? And the largest between in x is 7, the largest in z is 6. But which one is larger between 7 open and 6? It's 7 open. So you pick the 7, then you open, alright? So this is how you find the union. It's a combination of the two sets. So you pick the largest amongst the two, the smallest amongst the two sets, and the largest amongst the two sets, alright? Since there are just the two of them between the two sets, right? So you pick the smallest between the two sets and the largest between the two sets, alright? Then I'm going to find the complement. So the complement of this, I'm going to do the same thing. So we'll draw the inverse set up to 10, then I'll put -2 and 7 there, right? So now I'm going to put -2 and 7. So we have -2 here and we have 7, right? So you do the same thing that I did, and basically you're going to have an easier way of finding the final answer, right? So I don't want to repeat myself because of time, right? So we're saying, first of all, draw the universal set, right? Then we're going to put the set x union z, so it's -2 here and 7. Then after that, we're going to say what's happening here is closed, here it's open. So this is x union z, right? Then if I'm looking for the complement, if I remove this from the inverse set, what remains, this part -2 was part of, so it has gone, it's now open. Here is closed, so this is x union z complement, right? Then here it was open, so it's now closed. Then here the 10 is closed, so this is x union z complement. So meaning x union z complement is these two, which is -5, -2. All right. Then union closed at 7. Now, pardon, the -2 is now open, so you open it at -2, right? Union 7 is closed and 10 is closed. So basically this is what you have as x union z complement. So this is x union z complement, alright? So that's your x union z complement. Alright, we move on. Moving on, we go to the next question. C, alright, so let's go to C. Okay, so C part 1 expressed there's decimal, so 9.999 bar, right? So the bar is on all the 3 nines, so the 3 nines are repeating, right? So the repeating part is this. So how many decimal places are here? So I'll have my first equation as y is equal to 9.999 bar, right? Then my second equation, I'm going to multiply first equation by 1000 because there are 3 here. So I'll have 1000 y is equal to 999.999 bar as equation 2, alright? So this is equation 1. Then equation 2 minus equation 1, we're going to have, this is going to be 999. Remember, it's 999 because 1000 minus 1 is 999. Then 999, oh, let's put it here. Yeah, it's fine. 999. So what this implies, or this is equal to 9999 is equal to this. We have okay. Y. So this is y. 999y is equal to, what is 999? 99 minus the 9, right? So what we get now is we're going to have 900, 9990. Okay, so 9,990. All right, so divide both sides by 99 over 99, right? So y basically is 9,990 over 999. Okay, so if you see, this can actually go into this 10 times, all right? So we have 10 over 1 as your final answer, right? So that is your final answer. Basically, it's 10 over 1, okay? All right. Next up, part 2. Prove that 1 over root 2 is irrational. Okay, so we've been taught to prove that that one is irrational. Okay, so how do we prove that that is irrational? So we have 1 over root 2. So we first assume that 1 over root 2 is rational, alright? So we first assume that 1 over root 2 is rational, meaning it can be expressed in the form A over B. So in this case, it can be expressed in the form P over Q, right? So this is going to be P over Q. Right, so now from there I'm going to cross multiply, then you notice that Q is equals to root 2 multiplied by P, then over P, then root 2 is equals to Q over P. Alright, now ladies and gentlemen, what you need to note is, before you even write this, okay, if you must state to say 1 over root 2 can be expressed in the, we first assume 1 over root 2 is rational, meaning it can be expressed in the form P over Q, where Q is not equal to 0, and P over Q is in its simplest form, alright? So we assume that this thing is what? Is rational. So we're proving by contradiction. So we are saying, assume that 1 over root 2 is rational, right? Right, meaning that it's in its simplest form, okay? It has no common factors, that's what we mean. Then after that, that's when you come to this part, when you say 1 over root 2 is equal to P over Q, then I just cross multiply, or alternatively, you can just prove that root 2 is irrational. When you prove that root 2 is irrational, your conclusion will be, we know that 1 is rational. So a rational number over an irrational number is still irrational. Okay, so a rational number over an irrational number is still irrational. So you can prove just root 2, then you say a rational over an irrational is still irrational. Okay, so from here, what we're now going to do is we want to get rid of the root, so we square both sides, then we are going to have 2 is equals to Q squared over P squared. When we cross multiply, you notice that Q squared is actually equals to 2P squared. Alright, so this is equation 1. Right, so Q squared is equals to 2P squared. What does that entail? It means that actually Q squared is even, alright? So we know that from here Q is actually even because it is a multiple of what? It's a multiple of 2. Any number which is a multiple of 2 is even. So meaning Q is actually even. That is, so from here we're saying, from equation 1, okay, Q is even, right? Then we say that is, so Q is even, that is, there exists a constant or a number K such that Q can be written as 2 times K. Alright? So you can actually state it like that. So there exists some number k or some constant k, which when you multiply by 2 will give you q, right? So that's what we basically mean when we say that, all right? So it's a multiple of 2. So q must be even, okay? So now this k is actually an integer. So there exists a constant k which is an integer, right? So there exists, let's write constant instead of constant k, which is a number, which is an integer, right? So there exists an integer k, or let's say a number k, which is an integer such that q is equals to 2 times that k, right? Then we're going to replace q is equals to 2k into equation 1, right? So we're going to replace that into equation 1. So we're saying replacing q is equals to 2k into equation 1. We're going to have that as 2k squared is equals to 2p squared, right? So we have 4k squared is equals to 2p squared. Then I'm going to divide both sides by 2, right? Then we have p squared is equals to 2k squared, right? Now, what does that mean, right? It means that p is actually also even. So this is equation 2, okay? So I'm saying from equation 2, we can actually see that 2 is actually, p is also a multiple of 2, okay? So from equation 2, we can see that p is also a multiple of 2, okay? So we're saying p squared is even as it is a multiple of 2, right? So we're saying that p squared is actually even because it's a multiple of 2, okay? So p squared is even as it is a multiple of 2. All right, which means there exists so which means that p is also even, all right, or multiple of 2. That is, okay, so p is also a multiple of 2, right? Okay, so both p squared and p are multiples of 2. But what does that mean? If that is true, then we'll say, but 2 was a factor of what? Was a factor of q from equation 1. We could see that q was actually a factor, 2 was a factor of q. And then this same 2 is a factor of, is also a factor of p, all right? Which means that q over p is actually not in its simplest form, all right? So we're saying that since 2 is common to both p and q, this contradicts, okay? So this contradicts our assumption that this contradicts our assumption that q over p is in its simplest form. Hence, root of 2 is actually irrational. Okay? Then, apart from that, since we've said root of 2 is irrational, or we've said that 2 is common to both P and Q, from here again, you'll notice that P, 2 is a factor of 2, and 2 is a factor of P, and 2 is a factor of Q. Meaning this thing also, 1 over root 2 is irrational. That's the conclusion, alright? So since we're saying the 2 is common to both P and Q, we've realized that root of 2 is actually irrational. Then apart from that, this means that the P over Q is irrational because 2 is common to both P and Q. Alright, so that ends that question. Okay. Okay, so next up, let's look at a different question. So that was C. So we've done we've done B and C. Let's look at D. Okay, so let's look at question 2 now. Okay, let's look at 2A. Let's look at 2A. Okay, so 2A says x star y is equals to x plus y over x minus 3. Alright? X star y is equals to x plus y over x minus 3. The first question says, is star associative? Okay, so is star associative? In short, what they are asking you is star associative, right? Is star associative. So meaning that A star B star C should be the same as if you started with A star B star C. Right? So let's just consider one side. Maybe we start with the right hand side. So from right hand side, what's the first thing that you need to do whenever you're dealing with a binary equation, okay, is ask yourself that simple question, which is, what does the star do? Okay, so under binary operations, ladies and gentlemen, under binary operations, what you need to know is that we start from the basic operations, okay? So they are probably, they're actually likely 4 basic operations, the ones that you are common with. We have addition, we have subtraction, we have multiplication, and we have division, all right? So those are the 4 basic operations, but then operations can become more complex, all right, than just adding, subtracting, multiplying, and dividing. So when the operation becomes more complex, you need to understand what does the operation do, the one that has been given in the question. So according to the question that we've been given, we were told that x star y is defined by x plus y. So x star y is defined by x plus y over x minus 3, meaning to the first number, add the second number over the first number, then subtract 3. To the first number, add the second number over the first number, then subtract 3. So this is what this operation does. To the first, add the second number over the first number, then subtract what? A 3. So this is what the operation does. Okay, so when you understand what the operation does, it will be very easy for you to relate. So first number, add the second number over the first, then subtract 3. All right, so basically that's what the question is all about. That's what we've been told that binary operation does. Right, so now that we know what the binary operation does, the next thing that we need to know is How do we then apply it? Alright, so right hand side is this. So I start with whatever is in brackets, alright? So what's in brackets? We have B star C, right? Then, okay, maybe let's start from left hand side instead. Okay, so left hand side we have A star, B star C, right? So starting with left hand side, we know that this is now the first number. So we're starting with what's in the brackets, alright? So starting with what's in the brackets, we say first number, which is A, then add second number over to the first number, which is A, okay? So second over, then subtract what? A3, right? And then star C, right? Then for some of you, you can say, we'll let, okay, maybe let's not go there. Let's just continue like that. Right, so mean this whole thing here becomes the first number and C is now the second number. Ladies and gentlemen, this whole thing here becomes the first and now that is the second number which you have there. Alright, so we're going to apply the same principle. So we're started with brackets. This term means add first over second over first, then minus 3. So this is now the first, this is now the second number. So we are going to say to the first number, okay, so the first number is A plus B over A minus 3, right? We're going to add the second number, which is C, over the first number, which is A plus B over A minus 3, then we're going to subtract a 3, alright? So this is basically how we get to that, alright? So we're saying the first number in this case is this whole thing, then plus the second number, which is C over the first, and subtract a 3. Okay, so when you simplify that, okay, so when you simplify that, what you basically get. Let's maybe do a bit of I'll not do some simplifying. So what we will do is we'll consider the first part. Alright, so we'll consider the first part. We have this thing here, the common denominator is A, right? So whatever I change here, this is over 1, this is over 1. So if we pick A as the common denominator, what do we have? So we have A, then we have A plus AB, then minus, actually it's A squared, yeah, so this is A squared plus, then we have B, then minus 3A. Alright, so this thing is basically what is here in the denominator. So plus C over, we're going to have A squared plus B minus 3A over A, then everything minus 3. Okay. Then the second one will flip. So we have A squared plus B minus 3A over A, because division of fractions, it will flip, it becomes multiplication, so it's AC over A squared plus B minus 3A. So what I've done is, the second part, it was the same as C, then multiplied by A over A squared plus B minus 3A, right? So this is where we're getting the AC over A squared plus B minus 3, right? So it's like I've just flipped it. Then we're subtracting what? A minus 3 there. So now, if I say this is over 1, what's the common denominator now? The common denominator is A multiplied by this, right? So basically speaking, the common denominator now is A. But if you're multiplying by A, then we can actually say A to the power 3, okay. A multiplied by A squared plus B minus 3A is a common denominator. Then A into A, so this is the same as this is B multiplied by this, alright? So we have A squared plus B minus 3A then a squared plus b minus 3a, then plus a times that, that's a squared c minus 3 open brackets. This times this, we have a to the power 3. Okay, let's try like that. A squared plus b minus 3a, right? So that's what we have there. Okay. Okay, so from here what we are going to have now is, okay, so a squared times a squared is a to the power 4. A squared times b, that's a squared b minus 3a to the power 3. Okay, then plus b times that, that's a squared, so b times a squared is a squared b, then b times b plus b squared, then b times 3a minus 3ab, then minus 3a multiplied by 3a, so we have minus 3a multiplied by 3a is minus 3a squared, minus 3a multiplied by b is minus 3 ab, then minus 3a multiplied by minus 3a is plus 9a squared, right? Then we are still on the numerator, okay? We're still on the numerator. Alright, so since we're still on the numerator, the next part that we're going to get is we're now having plus a squared c, right? Then minus 3 times this is going to be negative 3a to the power 3, then minus 3b, then plus 9, negative 3 times 3 is 9, so 9a, right? Then everything over. The denominator is a to the power 3 plus ab minus 3a squared, right? So basically that's what we have in the numerator. Then when you simplify that, by adding like terms together, the like terms we have a to the power 3. So a to the power 3 we have 2a to the power 3, so they will become 6. Okay, so the answer of a to the power 4 is just alone. So then we have a squared b. Okay, so we have the next one. If you look at a squared b, we have another a squared. Do we have another a squared b somewhere? Okay, yes, we have another a squared b there. So we have a to the power 4. Then we just collect the a's alone, okay, in that order, or maybe let's just make it the way it looks. Minus the next one is a squared b, so it's going to be plus 2 a squared b, right? Then the next one is a cubed, so minus 3. And there are 2 actually, so we have 6 a cubed, right? So minus 6 a cubed. Then after that we have b squared. We have b squared. So on the b squared, we only have one b squared actually. Yeah, so we only have one b squared. So plus b squared. Okay, so we'll rearrange them later. AB. So if you consider the part which talks about AB, if you consider the part for AB, we have three ABs. So if you look at the ABs, we have two of them. So it becomes minus 6AB, right? Then from AB, we have the A squared, right? So, of course, A squared, we have 3, we have negative 3A squared, we also have another one. So we have minus 6A squared, right? Then apart from the A squared, so we've actually taken note of A squared, we've taken note of B squared. Let's talk about just the B, right? So the components that we have a to the power 4, we have 2A squared B, we have 6A, we have 6A to the power 3. Okay, so we have 2A squared B, then we have 6A squared, noted. We also have negative 6AB, we have negative 6AB, noted. We have the A part, right? So we have two of them which you've not written, where we have the A part where A is raised to the power 1. So if you check where we have A raised to the power 1, we only have one of them, right? Which is actually 9A. Okay, so we have 9A, all right. Yeah, so we have 9A, right? Okay, so from there, and we have the B. So if you look at the component with only B, we have minus 3B, right? Then we also have minus 3B, so minus 3B, right? Then we have just A, right? So the one which we have that just has A is the last part. You notice that the last part is plus 9A, right? So over A squared plus B minus 3A, right? So if I'm going to write that in an order, okay, so let's write that in an order. Okay, so there's basically one which is missing. Yeah, we have one missing, right? We have one missing. Let's just check which one is missing. Alright, so writing that in order, we actually are going to have a to the power 4, okay, minus 6a to the power 3, plus 6a squared, then plus 2a squared b, then plus a squared c. Okay, so that is a missing component, a squared c, so plus a squared c, right? Minus 6ab plus 9a minus b squared minus 3b, right? Then everything is over a squared plus b minus 3a. Okay. So basically that's the final answer which we get. Okay, so that is just one side which we've been doing. Okay, let's consider now the other side. So that was left hand side, now we want to find the right hand side. Okay, so right hand side, right hand side we have A star B star C. Alright, so the first number here is A, so it's the first number plus, okay, let's first deal with what is in there. B star, so the first number is B plus second C over B, then minus 3, alright? From there, then now what we have here is the first number has changed. So this now is the first number and this part is the second number, right? So it's going to be A plus second number, which is B plus C over B minus 3 over first number, which is A, then subtract minus what? Minus 3, right? Then we're going to flip what is flippable, right? And leave what is not flippable. Okay, so flipping what is flippable. From the numerator, you notice that the common denominator is B, right? From the numerator, the common denominator is B, so we have A plus B over 1 plus C over B minus 3 over 1. Then everything is being divided by A, then subtract a 3. Okay. Then we're subtracting a 3. Try to make it more visible. So we're saying this is A plus B over 1 plus C over B minus 3 over 1. Then we're dividing this by A, then minus 3. Then we have A plus common denominator is B, so we have B squared plus C minus 3B, alright, divided minus 3. Then we have A plus B divided by A, alright, so we have B squared plus C minus 3B over B multiplied by 1 over A minus 3. So we now have A plus B squared plus C minus 3B over AB minus 3, alright? So now, does that look like the previous one which we have from finding? Of course it doesn't, so meaning that those two are not associative, alright? So since the two do not look the same, we conclude that star is not associative. Okay, so if we want, we can actually make this, using this as a common denominator, alright? So the final answer will become AB, then we have A squared B plus B squared plus C minus 3B minus 3AB, right? So that becomes your final answer. So that's the final answer we should get. But as I said, since the two do not look the same, we conclude that those two are not associative, alright? So since they don't look the same, we conclude that the two are not associative. Alright, let's continue. So we now have a question that is asking us to evaluate, right? So the next question is saying evaluate. So what do we do? Okay, so let's evaluate that. Okay. So we've been told to evaluate 3 over 2. Star, negative 3 star 6, then star 5 star 10. Okay, so basically that's what you have. Okay. So now, whenever you're given such a question, let's consider them in parts. Alright, so I'll write it in parts. Let's start with 3 over 2, star 9 over 4. Okay, so 3 over 2 star 9 over 4. The first number is 3 over 2. Then add the second number over the first, so it's 9 over 4 divided by the first number, which is 3 over 2. Then subtract a 3. Okay, so basically that's what we're taught to do. Okay, so from here we are going to have 3. Remember, this one was first, right? So BODMAS gives respect to division, multiplication, addition, and subtraction. So 3 over 2, then plus 9 over 4, then multiplied by 2 over 3. Okay, then subtract 3. This is actually 2. We have 3 there, 1. So if you look at what has remained, we have 3 over 2 plus 3 over 2 minus 3. Okay. Okay, so we have 3 over 2 over 3 over 2 minus 3, which is 6 over 2. 3 plus 3 is 6. 3 plus 3 is 6, yes. So this is 6 over 2 minus 3, which is 0. Okay, so because it's 3 minus 3, which is 0. Okay, so I found 3 star. Let's now find negative 3 star 6, right? So to find negative 3 star 6, is going to be the same principle. Okay, so negative 3 star 6, let me write it here, negative 3 star 6 is equal to first number is 3. Add the second number over the first number, then subtract a 3. So this is going to be negative 3. 6 over 3 is negative 2, so minus 3. Negative 3, negative 6, negative 8. So this is negative 8, alright? Then lastly, what I'm going to do is now I want to evaluate 5 star 10, right? So I now need to evaluate 5 star 10. 5 star 10, the first number is 5 plus the second number 10 over the first number 5, then subtract a 3. Then we have 5 plus 2 minus 3. 2 minus 3 is negative 1 plus 5 is 4. Alright, so basically that's what you have. Then after you find your final answer, replace it in the original, right? So most of you sometimes wants to do everything at once. I don't usually advise that, but whatever suits you, as long as you get the correct answer, that's what matters to us, right? We'll mark you based on your effort. Whichever direction you choose to use, we'll mark you on your effort. So, what then are we saying? We know that 3 over 2 star 9 over 2 is 0. Okay, so if I'm going to replace the component, so 3 over 2 star 9 over 2 is 0, right? So we have 0 star, okay, then negative 3 star 6 we found as negative 8, so we have negative 8, right? Right, so I'm just replacing. We found negative 8, then star 5 star 10 is 4. Okay. So let me write this so that it's reasonable. So I'm saying 3 over 2 star 9 over 4, then star negative 3 star 6, close, then star 5 star 10. Okay. This is what we have. So what I'm saying is I'm replacing this by its final answer. We found 3 over 2 star 9 over 4 as 0, alright? And we found negative 3 over star 6 as negative 8 from here, and we found 5 star 10 as 4. Okay, so now I'm replacing the components, alright? So we have 0 star. Here we found negative 8, then we have star, here we found 4. Okay, so now we have 0 star negative 8, 5 star 10 is, we found this as 4. 2 minus 3 is negative 1 plus 5 is 4. Remember how we got to this? We said 5 star 10, the first number is 5. Plus the second number is 10 divided by the first number, 5. So this is why we get 10 over 5, right? Then minus 3, because it's a standard. The operation in question always subtracts a 3 in that order, right? So first number plus second number over first number, then subtract a 3. So we ended up having a 4, okay? So this is a 4 which I've written there, right? So even if you say 5 plus 2 is 7, minus 3 is still going to give you 4. Right, now, from here, we're going to have 0 star 8, because we have to start with what's in the brackets. So 0 star 8, the first number is 0, plus the second number, negative 8 over the first number, which is 0, right? Then subtract what? Subtract a 3, then star 4. Okay, now you know that any number divided by 0 is undefined, so meaning this whole thing is also undefined. Since any number divided by 0 is undefined, this whole thing is also undefined. End of question. Okay, so for those who are wondering how 3 over 2 star 9 over 4 became 0, so this is what we said. We said the first number here is 3 over 2, right? So this is first number, 3 over 2, then plus second number, 9 over 4 divided by first number, 3 over 2, then subtract a 3, right? Then this was 3 over 2 plus 9 over 4, division changes to multiplication, there's a flip, okay? So 3 into 9 is 3, 4, 2 into 4 is 2. So we have 3 over 2 plus 3 over 2 minus 3. 3 same denominator, so this is the same as 6 over 2. Okay, so yes, this is 6 over 2. This is the same as saying 3 plus 3. Okay, minus 3. So this is basically 3 minus 3. So this is 6 over 2 minus 3. which is 3, which is 0. Okay, so because 6 over 2 is actually 3. So 3 minus 3 is how it goes to the 0. So this is the component which we have 0 here. It's the 0 which I'm written here, right? So that's the 0 for this part. Then here we found negative 8. Then here we found positive 4. So now replacing, starting with what's in here, I was saying the first number is 0 plus. The second number is negative 8 over the first number 0, then subtract a 3. But this is undefined, so meaning everything here becomes undefined. Alright, so that ends that now. So let's start about binary. Okay, so let's look at a new set of questions. Continuing from where we ended. Okay, so the next question says, part 3. Does R have an inverse with respect to star? Right? Does R have an inverse with respect to R? Does R have an inverse with respect to star? So we're saying, in order for us to determine if R has an inverse with respect to star, okay? So we first need to determine if R has an identity with respect to star. Okay, so we want to know, does it have an identity before we can actually find if it has an inverse? All right. Now remember that if you have an identity E, this should be the same as A star E. Should be the same as E star A, right? And this should give us A. So if an identity exists, then that should be true. A star E should be equal to E star A, and that should be equal to A, right? So that's basically what we need to find out if that's true. Okay, so now we know that okay, so what is A star E? A star E, the first number is now A, plus the second number E over the first number A minus 3, okay? If you say over 1, and you have A here, so you have A squared plus E minus 3A, alright? So common denominator is A. 1 into A is A squared, is A times A squared, then A into A is A. A into A is 1 times E is E, then 1 into A is simply A times 3 is negative 3. So that is what we have. Then what is E star A, right? So E star A will be, the first number is now E plus the second number, which is A over the first number E, then we subtract a 3. So common denominator there now becomes E, alright? So 1 into E is E squared, plus E into E is 1 times A is A. 1 into E is E times that minus 3E, right? So this is E star A. But what do you notice? You notice that A star E is not equal to E star A, meaning that the identity does not exist, right? So we're saying, since A star E is not equal to what? Is not equal to E star A. E does not exist. Okay? If E does not exist, it implies that the inverse also does not exist. Since E does not exist, it implies that the inverse does not exist. So that's how you answer that question, right? That's how you answer that question. Okay, so let's look at another question. Let's look at another question. Okay, so the next question says, we're done with that. So that's how you prove it, all right? So if it doesn't have an identity, it doesn't actually have an inverse either. Okay, so C says rationalize. Okay, so we're now rationalizing. Now express root of that plus that in the form of P plus that, all right? Where P and Q are real numbers, then state the values of P and Q. Okay, so what you've been asked for here is basically, you've been asked to rationalize. Wow. So you've been asked to rationalize. Okay, so how do we rationalize? So we have root of 5 plus 1. Okay, root of 5 minus 1. I'm going to multiply this by its conjugate, okay? So what is the conjugate of the numerator there? Let's try writing it from multiply this by its conjugate. Okay, so this is root of 5 plus 1 over root of 5 plus 1. So this time this is root 5, which is just 5, plus root 5 plus root 5 and plus 1. Okay, unfortunately it's difficult. So we're saying this time this is simply root 5 so root 5 this is 5 plus root of 5 plus root of 5 plus 1 over, remember that the denominator is difference of 2 squares, so it becomes 5 minus 1, right? So we have 5 plus 1 is 6, so 6 plus 2 root of 5 over 4, 5 minus that is 4, so this is 6 over 4 plus 2 over 4 root 5. Okay, so the final answer is simply 3 over 2 plus 1 over 2 root 5. Okay, so P there is 3 over 2 and Q is actually 1 over 2. Okay, so your P is 3 over 2 and your Q is 1 over 2. Okay, so we're saying, therefore, P is 3 over 2 and Q is close to 1 over 2. Okay, so that having been said, this marks the end of this tutorial. Okay, have a good day.